Alright everybody, here is the arsenic that we're going to be using for our experiments. This is 5.03 grams of elemental arsenic. You can see normally it's shiny and metallic looking, there it is. But arsenic, when you find it in its elemental form, is always covered with a layer of black oxide. So, unless you store the arsenic under an inert atmosphere, it's pretty much always going to look like this. But this isn't a problem. I mean, the nitric acid will take care of this in no time. But there you go, people. That's what elemental arsenic looks like. It's, it's brittle. It breaks easily. It's it's not really that hard. Very, very interesting element. Alright everybody, I am measuring out the nitric acid now. And here we go. There's 10 mils. Let's just see what that does at first. Now, if I recall correctly from last time, you had to heat this up and you had to do it for a while in order to get the arsenic to all react with the nitric acid. Now, this is, I think it's like 63% nitric acid. This is the good commercial grade stuff. And as you can see, it's really not doing much of anything, which is exactly the way it was last time. And if you think this is bad, you should try dissolving it in sulfuric acid, which exclusively produces arsenic trioxide, if I recall correctly. But it takes for freaking ever. Kind of like the cadmium. It was about at that same speed. It was very annoying. Alright, so we got 20 mils of our concentrated nitric acid in there. Let's turn that down. And now, here we go with the 35% hydrogen peroxide. We're just going to add a little bit. Now, I'm going to tell you, I've never done this reaction before. I've never tried adding hydrogen peroxide to it. But in the article about arsenic acid on atomistry, it was actually just on the chemical properties of arsenic itself, they mentioned that arsenic will react with hydrogen peroxide to exclusively produce arsenic pentoxide. So if you dissolve arsenic in concentrated nitric acid, which will give, like I said, I've read things in some places where it says it will give you a mixture of oxides. I've read in other places where it says concentrated nitric acid gives you pretty much exclusively arsenic acid, so arsenic in the +5 state. It's a little confusing. So I figure, we'll add in the hydrogen peroxide. That way we know for certain that everything that's dissolving in here is turning into arsenic 5, that it's turning into arsenic acid. And that way we'll be sure of what we have in here. Alright. It looks pretty tame, all things considered. It's bubbling pretty good. Okay. Oh, that's the bubbles being suspended. But yeah, you can clearly see where pieces are reacting. Now, that's interesting too, because I turned the heat down, but it's still steaming. Interesting. Well, let's turn the heat up a little bit. Give it a helping hand. And let's cover it with watch glass, because there are all kinds of leaves falling out of the trees, and so the last thing I need is a leaf falling into my experiment and ruining it. Alright, well, I will come back once this is done, and there's something else for y'all to see. Oh, before I go, I wanted to show y'all some other compounds that I've made with arsenic. These are basically all arsenates, or mostly arsenate, and just combined with different transition metal cations. So, this, whoa, okay. Something happened there. Oh, alright. Buildup of nitrogen dioxide. Cool. No, we'll just leave it uncovered. I guess we'll take our chances. Anyway, as I was saying, this is manganese arsenate. So it is manganese plus 2 combined with the arsenate ion. This is, where is that? Oh, come on. There we go. This is nickel arsenate. And last but not least, my favorite one. This is cobalt arsenate. And that is just like the most vivid magenta I've ever seen. Although it looks more purple on here than it does in real life. But anyway, I just thought that was really cool. And I thought I would show y'all. So yeah, like I was saying, arsenic makes very colorful compounds. And this is what I got the first time I tried to make Paris green. I mean, it's definitely green. So I feel pretty confident that if we use this, we should be able to make something that approximates Scheele's green as well, which I've never made. I'm pretty sure that my Paris green is going to turn out okay, since I've done it before, but Scheele's green is one I've never done. So we'll have to wait and see. Alright everybody, it's happening. I don't know if you can see this. No, I don't see how you can miss it. So we're going to back up from this a lot. Thank God it's a very windy day today. That is supposed to only be giving off oxygen. Obviously something has gone wrong. That's exciting. Well, that was exciting. I am fairly sure that some of that is water. And probably some other breakdown products. I probably heated it too fast. So we're going to abort this part of the experiments here, because fuck all of that. I might be crazy, but I'm not stupid. And yeah. No, we're just not going to take a chance, because I have no idea what the hell that was. I mean, that wasn't oxygen. I'm sure some of it was oxygen, but, yeah, no. I don't know what the hell that was. So, we're going to err on the side of caution. Well, I mean, I don't smell any kind of garlicky odor, which tells me that it's not arsine, at any rate. It did rise, too, fairly consistently, so it was light. Also not arsine, probably steam. But no, that just yeah, that's going a bit too far, and we're just gonna say no to that one. All right, everybody. Not all of the arsenic has dissolved in here, but I think we've dissolved enough for our purposes. I mean, even if I only convert a few grams to arsenic acid, that will still, we'll still be able to make Scheele's green and Paris green without any issues. So I'm going to go ahead and shut this down now, and I'm just going to let it cool off on its own. And then once that's done, I'm going to come back and we are going to neutralize this with sodium hydroxide to produce a solution of sodium arsenate. Alright everyone, so this is the residue that was left over after I tried to thermally decompose that mixture of arsenic 3 and 5 oxides. When I weighed this, I mean originally it weighed 2.9 grams. But now it's lost almost a full gram of weight just in that short amount of time it was heated up. So what I'm going to do now is I'm going to put a little bit of water in here and see if this dissolves. If it doesn't dissolve, then that's pretty good evidence that it did indeed reduce down to mostly arsenic trioxide, and yeah, that it worked fine. The arsenic 5 arsenic pentoxide, is fairly soluble in water, so it should dissolve. So, I mean, I can just filter out the arsenic trioxide after I do this. So, should be a way to separate them more or less. Alright, everyone. In order to make Paris green, we have to react our arsenite or arsenate with copper acetate. So what I did, since I didn't have any in my inventory, is I went ahead and made some up this morning, and this is it. And check this out, y'all. Look at that. It is sparkly and beautiful, and I love everything about it. That is just gorgeous. So all I did was just dissolve basic copper carbonate in glacial acetic acid, and then I just kept going with it until it crashed out of solution, filtered it, dried it in the desiccator over sodium hydroxide pellets, and put it out in the sun to speed up the process. And yeah, man, it dried it out real damn quick. That's about as good as 3 angstrom molecular sieves, but you know, I think this might ruin sieves if you try to do it with that. But anyway, so I just wanted to show you this because it's absolutely fucking gorgeous and it sparkles, and I just love everything about it. So anyway, thought you might like that. Alright, everybody, this is how much arsenic trioxide was left over after that calcination. So, a fair bit of it. Although, it obviously did get some of it. So, anyway, I mean, I guess it's a viable process, but man, you should absolutely do that outside when you're not doing it. Far away from people, where the wind is going to carry that stuff away, just away from everything. So, yeah. Important safety tip. So it's been 2 days since I shot that last segment, and I had to wait that long because it rained. It's only just now cleared up. And I didn't want to do this when it was overcast because I wanted y'all to see the colors as true to life as possible. Now, I am going to go ahead and forewarn you that the primary thing that determines the actual shade of green that you get out of these products is the grain size. So it's how finely ground it is. The coarser grain materials gave a darker green. The more finely ground materials gave a lighter green. So that's why these compounds could have a variable composition and yet still give basically the same colors, because it could be ground until it very closely matched the shade that you were after. But anyway, since we know that historically these compounds were mixtures of arsenates and arsenites, what I've done in the time since I last filmed anything was I went ahead and I neutralized the arsenic acid, and I dissolved the crust of arsenic trioxide in the crucible in aqueous sodium hydroxide and transferred it into here. So this solution of sodium arsenate, I don't know how concentrated it is, but suffice to say it's a lot more concentrated than this. So what I think I'm going to do is I'm going to put about 50 mils of the sodium arsenite solution in each of these beakers. There's another one off screen, just like this one. And I'm going to put 10 mils of the sodium arsenate in there. That should give us, I hope, something that reasonably approximates these historical compounds. What I have here, this is a solution of copper acetate, and this is a solution of copper sulfate. This will be used to make the Scheeles green, and this is going to be used to make the Paris green. So, I guess, let's just go ahead and do it. Alright everyone, we have our mixture of arsenite and arsenate. Here we go with the copper acetate. See if we can do Scheeles green. Oh wow, that turned out a lot better than I thought it would. Oh, that's fantastic. Look at that, that is beautiful. Oh, that is amazing. I guess we'll just, yeah, add as much as we can, because, I mean, we'll just decant off the excess copper sulfate solution. Because, yes, these are going to go into my inventory until the end of time. There's no way to really dispose of them. Alright, y'all, so that's Scheele's green. Now for Paris green. So let's try it like this. Here's a little bit of the solid copper acetate. Let's dissolve it in a little bit of water. Alright, let's try this. Because, like I said, that other solution had acetic acid in it. So maybe, somehow, some way, that screwed it up. No. Okay, maybe I went in the wrong direction. Is it not alkaline enough? Oh, she's turning green. Alright, it was too acidic. I guess that makes sense. Alright, kids, now we know. When you're making your Paris green, make sure it's very alkaline. Although maybe not that alkaline. Damn it, we had it. Did we overshoot this? That's a very beautiful blue. Well, that's okay. We can go back in the other direction. Until we hit the perfect green. Okay. Okay, alright. Don't overdo it. Here we go. Here we go, come on. Now it's kind of looking a little brown. Alright, so apparently, it's not mentioned in anything, but the pH is very important. Come on, don't quit on me. Damn, we hit it and we passed it. Alright, we learned a lot from that one. Let's try it one more time and see if we can't pull it off. Okay. Last of the sodium arsenate. But by God, we will get it. Okay, let's add just a little bit of sodium chloride, because the pH of this stuff is about 9. So clearly that isn't alkaline enough after whatever acid is left in this copper acetate reacts with it. Come on. You need to get with the program. Okay. It's greenish. definitely green, but it's not the green I was hoping for. Let it react for a little bit. Let's see. Come on, baby, come on. I mean, it is green. It is technically green. I don't know if you can see it, but there are little particles in there that look pretty green to me. And like I said, the shade is determined mostly by the particle size. So, the stuff I got before is so much better. It was such a deeper, vivid green. But then again, it was big chunks. Alright. Am I willing to even call that Paris green? I don't know, y'all. You tell me. I mean, I would say that's little particles of it. Let's try this. Actually, let's do that. Let's see if we can collect enough of them on the one side to really get a good idea what the color actually is. Okay, y'all. I know it's not as impressive as actually making the stuff in quantity, but I give you Paris green. And Paris brown, apparently. Oh, that is so sad. Look at that shit. That is horrible. I don't even know what the hell that is. And then here is our much, much nicer Scheeles green. The only thing I can think about why it didn't work is because it was just too acidic before. Because like I said, the pH of the sodium arsenate was only 9. But apparently you have to have it much more alkaline than that, or you end up with sky blue, boring copper hydroxide. At least I assume that's what that is. I'm not actually sure. But I don't care, because it's totally not what I was going for. And it's a, oh my god, that is a really hideous color. Ugh, yuck. Oh well. Alright, let's get the good ones here. Yeah, there we go. Alright, y'all. So, didn't work out quite like I had hoped, but nonetheless, man, there you have it. Scheeles green and Paris green. And you know to make sure it's nice and alkaline. If you want it to actually work. So, anyway, I hope you all have enjoyed this video. If you have, please give it a like. If you think it sucks, give it a dislike. Comment, tell me I'm awesome. Tell me how fucking lame I am. And if you liked it, please consider subscribing and share the video. And until the next one, y'all, we'll see you later.